Well, hi there, folks. This is going to be our last new information before break, so get excited. It's going to take like 2 days to go over this, and then we'll just do some practice. I'll probably grade like 2 of the questions on your practice on Thursday. But if at any point you're struggling with how these work, please let me know through my office hours. I'm happy to help. The beginning of this is literally just going to review logs. I know, we don't love logs, but hopefully you remember a little bit about them. So what I want to remind you of is a few properties. The first one, think about if I take the log of 1, what it's really asking you for is, I'll show you over here. If you had me, you know the seashell method, so you could say ln of 1 equals x. The base for ln is always e. So to figure out what ln of 1 is, you can actually put it into exponential form. Looks like a little seashell, so it'd be e to the x equals 1. The only number that if you raise a variable or a base to it that gives you 1 back has to be 0, okay? Same thing with ln base e of e. Some of you might remember that this just cancels and gives you 1, okay? ln of a times b, just a reminder of some of the properties. Whenever you see multiplication, it's kind of like exponents, right? E squared times e squared is really e to the 4th. You add the exponents, same thing here. Ln of a plus ln of b. The tricky part is to remember you have to have an ln in both parts. What about power to a power? So if you have a power up here, it's kind of like having 2 squared to the 4th. You multiply those. So this is like magic. It goes in front. Becomes n ln of a. Okay, division, hopefully we remember, but it turns into, that's right, subtraction. Okay, those are some basic log properties. This is going to help us to take the derivative of them. Okay, so what I want you to do is just practice a little bit of those rules with just the first one. See if you can expand that. Think of those rules that you have. Pause the video for me and you'll see it when you get back. All right, hopefully you got ln of 10 minus ln of 9. That's all you can do, so you're done with that one, which is nice. This one actually you can't do a lot either because it's ln of 3x plus 3 plus 2 to the 1/2, like we're used to writing with radicals. So all you can actually do for this problem is bring that 1/2 in front. You cannot distribute a log through parentheses, and it doesn't work in the opposite manner. You can't turn this into multiplication or anything. So this would be your answer, just 1/2 ln of 3x plus 2. The next one involves multiplication and division, so just be careful. I want you to try it and see how far you get. Again, pause the video. I will have it done for you in a second. All right, folks, something you may have forgot is that if you have 2 terms on the top and the bottom, you're going to have 2 terms with addition and 2 terms with subtraction. If this confuses you, feel free to think about it instead as ln of 6 plus ln of x, right? Hopefully you're good with that because it's multiplication, minus ln of 5 plus ln of y in parentheses. And then you just distribute the minus sign. I always think it's much easier just to think if it's on the denominator, you're going to have subtraction in front of it. So this is the simplified version of that. Okay, the next one, it's a little bit more complicated because you cannot do a lot on the things that are on the inside. Again, you can't distribute an ln through, so just be careful of that. So I would personally start by writing it as ln of x squared minus 4 squared minus ln of x minus ln of x squared plus 1 to the 1/3, okay? Because then you can see separately what all those things are going to look like. So your final would be 2 ln of x squared minus 4 minus ln of x minus 1/3 ln of x squared plus 1. Okay, if you need more information on that during my office hours for it, okay? Kind of like the chain rule. All right. Again, this is just a refresher from pre-calc, so hopefully it's not too crazy for you. And then they also want you to just plug in values, basically. So it's kind of a combination of what we just looked at, but they also tell you what the values are. So what they want you to do is use ln of 5 and ln of 3 to approximate that. So what you want to do with this is expand first. So ln of 3 minus ln of 5, and then just substitute in what you know. So ln of 3 is the 1.099, and ln of 5 is 1.609. So you plug those in. So you get 1.099 minus 1.609, which ends up being about negative 0.51. The next one, you might notice you don't have a 3 and a 5 in here, but you can turn it into a 3 and a 5. So they're saying like, oh, this is the same thing as ln of 3 times 5, which then you can turn into ln of 3 plus ln of 5. Plug in the numbers. So ln of 3 is 1.099. ln of 5 is 1.609. And then you get about 2.708. Okay, try the next 4. When you're done, just after you pause the video, I'll have it up for you. Not with a ton of work though, so please make sure you check in with me if you have trouble. Alright, so check out those answers. There's actually a few ways to do these ones. You could turn ln of 3 and so you could do this is the same thing as ln of 3 times 3, which is the same thing as 3 squared. So either way you get the same answer, but just know there's a few different options for this one. Same thing with ln of 27 and ln of 25. Just check your answers and then we're moving on. Okay, so this is our basics of the natural log function. I'm sitting outside, so hopefully you don't hear all the yard work happening around me. But one thing that's kind of crazy is that if you take the derivative of ln of x, it is 1 over x. If you take the ln of u, it's 1 over u times the derivative of, oops, sorry. My iPad is being weird. Okay, so we're going to use that rule in a second to help us differentiate. So just notice that we're taking the derivative right now, not the integral yet. We'll eventually get there, but for now, just the derivative. Okay, so if I took the derivative of ln of 2x, think about, remember, the derivative of ln of x is just 1 over x. So my derivative is really, think about the chain rule. If you need to, feel free to turn this into like u so that we know du is going to equal 2, if that helps you out. So you can actually just turn this into 1 over 2x times the derivative of what's inside, so that would be 2 as du. So your answer ends up being 1 over x. This is one way. The other way to do this is actually take the properties of logs and split this up. So this is another option. You don't have to ever do this, but if you can see it better, feel free to use it. So this is the same thing as ln of 2 plus ln of x. You can actually split it. The derivative of ln of 2 is 0 because it's a constant. The derivative of ln of x, we said, is 1 over x. So you actually end up with the same answer. Totally optional how you want to do that. So I'm going to do the next one with you because it's a little bit more complicated. You have to be careful. So if I take y prime, the derivative is going to be 1 over u, right, which is x squared plus 1. You don't even have to do u substitution here because it's not an integral, but times the derivative of u. What's inside? Sorry, I keep hitting the bottom. So the derivative of what's inside is 2x, right? The derivative of x squared plus 1. So our final answer you can just write as 2x over x squared plus 1, and that's good enough. Okay, the next one, I want you actually to try it, but be very careful because think about what kind of rule you're going to have to use if it's x times ln of x. So pause. If you can try 2 and 3 at the same time, fantastic. Otherwise, feel free to watch what I do at the next step. Alrighty, so if you got 1 plus ln of x for number 2, fantastic. Remember this, you have to use the product rule. So first times the derivative of the second plus the second times the derivative of the first. So our first was x, so first times the derivative of ln of x is 1 over x, plus the second, the derivative of x is just 1, so that simplifies to 1 plus ln of x, which is great. This you have to use chain, so bring down that 3 in front, reduce the power, rewrite the inside. Take the derivative of the inside and multiply. And then I just rewrote it so it looks a little bit cleaner. Is when you, which is the same thing, derivative of... Alright folks, we are actually almost done with these notes today. There's not a whole lot to it, which is nice. The new thing isn't really even new to us. It says write the equation in the tangent line that has the point given. So all you have to do is take the derivative of the function and then plug in the point, which is what we're used to doing anyway. But I'll help you out with the derivative here. So the derivative of this would be 1 over the square root of x plus 1, but then you have to take the derivative of the square root of x plus 1. That's chain rule, so be careful. This is the same thing as x plus 1 to the 1/2. So if I do the derivative of that, it becomes 1/2 x plus 1 to the negative 1/2 times the derivative of the inside, which is just 1. So that was convenient. Okay. This ends up being your slope, if you forgot that. Okay. I'm actually going to make this a little easier for us and rewrite it too, so it's easier to see what it looks like. What ends up, simplify this. It ends up being 1 over 2. Because this is negative, it comes down. Okay, so it becomes 2 times the square root of x plus 1 squared, because there's 2 of them. Okay, so this actually simplifies to 1 over 2 times x plus 1, or 1 over 2x plus 2. So that's your slope. And then what you have to do from there is plug in the point. Okay, so plug that point in for your x value. So if I do f prime of 0, 1 over 2 times 0 plus 2, so my slope ends up being 1/2. And then feel free to write it in slope-intercept form, or I like point-slope form better because you could just do y minus 0 equals 1/2 x minus 0. Because remember, this point means 0, 0 is a coordinate, which simplifies, if you want to simplify that, it's actually 1/2 x. Okay. Try the next one for me, but be careful because it's a quotient rule problem. So hopefully that's still in your brain. Try it out. I'll have all the work done out for you in a second, but check it out. You could also, instead of using quotient, so some of you might want to use this instead, you can also use the properties of logs to split this up into 2 different expressions. That's totally fine. Just notice for this one, they just want you to differentiate and you don't have to plug in any points. So I'll show both ways if you would like, but try your method first and then unpause the video. Alright, so I showed both ways. I actually think the rules of logs is a little bit easier, so the right hand side, this part, because you can literally just split up the log into ln of 2x minus ln of x plus 3, and actually this would not be prime yet, it's just y equals, and then this would be prime, okay, because then you can differentiate that a lot easier. You'd probably want to get a common denominator here, and you end up with the same thing, the same answer, which is nice. Whereas if you go on the left hand side, this part, you have to do 1 over 2x over x plus 3, so that turns into flipping. And then you have to use quotient, so low d high minus high d low, all over low low. A lot of things cancel. You can hopefully see my work in there. And you end up with 3 over x squared plus 3x. So if you can use log properties, I would do it just because it's gonna be a little easier for you to calculate. And I would accept either option on assessment, so make that work for you. The next one is the most complicated, but it's our last of the day. So try it out. You don't have to do the bottom question, and that's your next set of notes, so that's for the next day. But try it for me. Again, I'll have all the work done out for you. If you want to use log properties, that's what I'm going to do, because it's, again, easier to work with instead of having to use product and quotient at the same time. Gross. So please try it out, and when you're done, I will have the work done for you. Alright, check it out. So if you use your log properties, it turns into that first line. Notice I haven't taken the derivative yet, so I wrote f of x equals. And then once you take the derivative, you just have to be careful to do, like this one is minus 1/2, so I wrote it as 1/2 times this stuff, and then times the derivative of the inside. You can leave your answer like this, especially when it's that complicated. If you did it the other way, you probably get the same answer, but a slightly different version of it. So just be careful. If you used product and quotient, it just ends up being a little complicated, or more so complicated anyway. All right, folks, enjoy the rest of your day. Please join my office hours if you are having any sort of trouble. Talk to you soon.